Hello everyone, welcome back to my channel. Today we are going to talk about the Kubernetes. So Kubernetes is a tool in DevOps. So by using this tool, we can manage our applications which are present inside the container. So using this Kubernetes, we can organize or else we can do scale or else we can do any sort of updations simply by using this tool. So we can manage our applications. Now let's try to understand why do we require this tool called Kubernetes. Without using this tool, managing lots of applications is a big headache. So this tool, what it will do means it keeps everything in control, even if the things are getting complicated. The creator of this Kubernetes is Google. So Google created this Kubernetes. They have used their own infrastructure to develop the Kubernetes. Now it is managed by global community and widely used now. Kubernetes, what problem does it solve means it automatically fixes the failure applications in order to distribute the workload. If you want to update your application, you can update the version of the application, and if you want to scale down them, you can scale down, or else if you want to scale up, you can scale up without much effort. So many of the people may have doubt how it is better than the traditional hosting. So what are some main features of this Kubernetes means? Kubernetes, when the heavy traffic is there hitting our application, so at that time also it will deploy many containers. The main feature of the Kubernetes is it will, when the traffic is very high, it will automatically scale up according to it, and even it will shrink the application when it was calm. So it can do cost optimization also. So like I said before, it can fix the failures for even if the application is getting failed, it will fix that problem also. So 24/7 it maintains runtime, so without any failure. So when we are going with the practical part, you hear about some technical jargons like the cluster is nothing but the group of nodes combined together. We call them as cluster. When the group of servers together, when we combine them, then we call it as cluster. So if you group the servers together, our applications will run smoothly. So this is the actual meaning of the cluster. Actually, in Kubernetes, some people will call it as nodes, or actually, and you will hear about the master node or else worker node. So wherever we install this Kubernetes, so that server we call it as master node, and where our applications and containers are running on those machines, we call them as the worker nodes. The complete management is taken care by the master node itself. People will call it as master node, and some people will call it as controller. Coming to the key parts of the Kubernetes, there are 5 building blocks like node, pod, deployment, service, namespace. So these parts together, each and every part have some goal, right? So to make everything work together. So what is pod? Pod is the smallest unit in the Kubernetes. Usually it runs one container. Now let's try to understand about the deployment. So deployment, by using this deployment, we can launch our pods. So we can manage our multiple pods together, and by using this, we can do some rollback and we can do some sort of updations, else we can scale our applications also. Next, coming to the technical jargon like service. Service is actually the gateway for your pod. So if you want your application to communicate with the outside world, by using this service option, you can do that. Now moving to the namespace, what is the purpose of this namespace means it helps us to organize our resources properly. Means when we are going with the big projects, we can manage our resources. You can think like the computer, how you organize your folders. In the same way, it helps us to manage our resources properly. So like we talked previously, how does the scaling work? Kubernetes, whenever the traffic is there, automatically it increases the pods. So in order to keep and maintain the availability for our application without going down. So whenever the traffic is not there, so automatically it's going to scale in our pods, or else when traffic is there, it obviously scale out. Kubernetes can do self-healing also. So if the pod is getting failed, automatically it will restart the pod. The main thing here, the application should not go down. So that's the reason always 24/7, as I told you, our application should be available. So it is going to do that job also. So it manages the pods actually. Now let's try to understand about the rolling updates. Rolling updates means if you want to make any changes for your application, what this Kubernetes will do means it will automatically deploy the newer pods one by one. So automatically the users cannot identify the change, what is happening actually. So this is what the application, if you want to do some sort of changes in your application, automatically this will happen because the Kubernetes will change the pod. So users cannot detect or identify what's exactly how it is. I would like to give you some real world example. You can consider or take example of the e-commerce websites. See, when there is a festival season, what this Kubernetes will do means at that particular day or as the time, the pods will automatically getting increased. So when the festival season completed, so automatically the Kubernetes understand the traffic and automatically it will reduce when the traffic is there, the high availability is there. So when the traffic is less, in order to save our resources and cost optimization, it will do that also. This is how it is going to work internally. Now, why should we learn Kubernetes? At present, Kubernetes is having very high demand. If you are a DevOps engineer, compulsory majority of the companies, when they want the real time, the real enterprise applications, this Kubernetes is much used. Okay, now let's move with the pictorial. I will give you the pictorial representation, how the architecture of the Kubernetes is. So let's go. Before moving to the practical part, now let's see the architecture of the Kubernetes. So it's very important to understand about the architecture of Kubernetes. Okay. So let me let me give you the pictorial representation of this Kubernetes, how the internal components are getting involved in the cluster. So let me show you cluster. Now I'm going to give you the pictorial representation here. Observe carefully. So assume that this is the cluster. So let me name it as Kubernetes cluster. I'm going to name it as Kubernetes. It's very important to understand the architecture. So observe carefully here. So cluster means nothing but the grouping of servers combining together. Okay. It creates a cluster. Then we call it as a cluster. Now inside this, I'm going to take two planes we have. One is controller plane. Inside this we have two planes. Controller plane we call it as. And I have the worker nodes here. This is the worker node 1, worker node 2, worker node 3. Okay. So this entire part is the data plane. This part we call it as, and this part we call it as controller plane. So we have two main parts here. One is controller plane and the data plane. So inside this data plane, we have different types of workers here. So in total, how many workers that we have means we are having 3 worker nodes we have. So let's name them as, this is the worker node 1, and this will be our worker node 2, and this will be the worker node 3. Okay. So in total we have the 3 nodes, and inside this, so together it creates the cluster. Now you understand, we have the controller plane. So this is the main controller plane. Inside this controller plane we have multiple manager machines. Okay. So or else you can say like supervisor. Okay. So we can have the multiple manager machines also. Okay. We can have the multiple manager machines, and in the data plane, as you can see, we have 3 worker nodes. So inside this worker nodes, inside the worker node, we have the pods. This is the second pod, and here also 1 pod. In the worker node 2, in the worker node 3 also 1 more pod is available. Like this, we call them as pods. This is the pod 1. This is the pod 2. Like this. These are considered as the pods. So inside this pod, what do we have? We have the containers. Again, inside the pod, we have the container. Inside a pod, you can have 1 container, or else you can have multiple containers also. So here We can have the multiple containers also like this. So here also you can have one more container. So inside these containers we have the applications, our apps which are running inside the containers. You can see here inside one pod we can have the multiple containers also. So if one container want to communicate with the another, or else if one container want to send files to the another containers, obviously what the pod will do, it will put both the containers in the same pod only. Okay, so in this way the pod will manage the containers. Okay, so the container will manage the applications. Okay, now inside the each and every, even in the manager node or else in the data plane node, one thing we see, the common thing, that is kubelet. Very, very important, this kubelet. It plays very major role. Okay, so what does this kubelet will do? I will tell you. Right. See, here also I am going to mention kubelet. Here also you will see the same thing, that is kubelet. Okay. So kubelet is actually, this is responsible for creating and managing the containers. Okay. So actually it will not, this kubelet will not create actually. There is one more thing I will tell you now. So it will manage the pods actually, not the containers. It's going to manage the pods, creating the pods, deleting the pods. Each and everything is taken care by this kubelet itself. Okay. So in the controller plane, you can consider this controller plane as the principal of the school. Like let's name it as principal. And this data plane, you can, whatever the worker nodes that we have, you can consider these things as the teachers. So, and these are the students. These pods, you can consider them as the students. For better understanding, just I am going to give you you can consider them as. So on a high level, for better understanding, I am going to mention like this. So just try to understand. Controller plane is going to manage everything. So it will take care about the data plane. So the teachers here, you can consider them as the worker nodes and the students as the pods, right? So, right. Now we'll discuss about the components which are there in the controller plane now. The very first important component that we have here is API server. In the Kubernetes controller plane, when we are discussing about the components, the first component that we need, that everyone should know about, the API server. Very important component it is. So what is the purpose of API server means? Now to interact with the Kubernetes, now assume that this is your computer, this is your laptop. With the help of kubectl, this kubectl is a command line tool. It is a command line tool. With the help of this kubectl, you are going to communicate with the Kubernetes. So the request will go to this API server itself. So what this API server will do means, it will accept the incoming request which are made by the user by using this kubectl itself, which are made by the kubectl, which is made by the user by using this kubectl. It's a command line tool actually. Okay. So this command line, with the help of this command line tool, user can interact with the Kubernetes, and this kubectl can be installed in our own laptop, or even on the server or as the PC, whatever, wherever you want to install, you can install this kubectl. So in order to communicate with the Kubernetes, first the request will go to the API server. So the API server will accept the incoming request which is made by the user with the tool called kubectl, command line tool called kubectl. Now the API server, what it will do means, so this API server, what it will do means, it will gather the information which is made by the user, and it will store the data in the etcd. Okay. So etcd is the another component in Kubernetes. So what is the purpose of this etcd means, it is going to store the data related to the pods, or else the nodes, or else the containers. Each and every data is getting stored here in the form of key value pairs. The data will be stored here in the form of key value pairs. It will dump the data here. It will send each and every piece of information to the etcd. Okay, etcd. There is one more component that is, there is one more component in the controller plane. There is another component in the controller plane, that is nothing but the scheduler. What is the purpose of this scheduler means? It will schedule the pods. It is going to monitor each and every node. So each and every node it is going to monitor and observe the resources that are consuming, and based upon that it is going to decide on which node the pod is going to get deployed, and decide and which on top of which node the pod should get deployed. This scheduler will decide that. The scheduler always tries to communicate with the scheduler always communicates with the API server and decides to deploy pod on which whatever the node is available. So it is going to get scheduled the pods. Okay. So just the scheduler job is to schedule the pods. Okay. Now very important component, that is nothing but the controller. Next component in the controller plane that we need to talk about, the controller manager. So this controller manager is very important component in this Kubernetes. So this component will monitor entire cluster. So this component is going to monitor entire cluster. So actually this will pick up the data from the ETDC itself. Check the amount of data that is available in the ETDC. So it is going to check like within the cluster, based upon the data, whatever the activity that is happening in the real time. So the entire activity is happening according to that or not. So if something is going to mismatch, it is going to inform to the API server. So immediately deploy these many pods or remove the pods. The information it is going to pass to the API server. So it will communicate, it will check. So you can consider this control manager as the supervisor. Okay. So in the control plane, control manager is like a supervisor. It is going to monitor entire cluster. Okay. Entire cluster is going to monitor and decides, fetch the real-time information always and bring data from the, gather info from the etcd, which is correct or not. So these type of checks this controller manager is going to do. Right. For important thing component, this component will be present inside the worker node itself. Okay. It means in the data plane, this component will be available, nothing but the Kube-proxy. So it will take care about the networking. Okay. Kube-proxy. So this Kube-proxy, what it will do, it will take care about the network. So the pods, how to communicate with each other. And if you want to manage your network, entire network. So with the help of this Kube-proxy, we can manage the network. Okay. So it will be available in the data plane only. Now, as we discuss here, the kubelet is responsible for creating and deleting the pods. And one more important component, it is also available in the data plane, that is nothing but the container runtime. Okay. So we can call it as the container engine, the main engine. So let me put it here. So this is the container engine. So this container engine is responsible for creating the containers. Okay. So it is responsible for creating the containers and managing the containers. So it will directly communicate with the Docker Hub, and whenever you want to create some container or else you want to delete or you want to perform any update or rollback, these all things, actually the container engine will do this job. So this is how the containers are getting managed by this container engine. So right. So this is the architecture of the Kubernetes cluster, right? So we have the once again, I'm telling you, we have two types of planes here. One is controller plane and the data plane. So you can consider this controller plane as the principal who manages entire school. Like, and the data plane is like, here you have the data planes. Inside this data plane, we have some worker nodes. So you can consider them as the teachers. And here we have the pods. Inside the pods, we have the containers. And pod is the smallest unit in the Kubernetes. Okay, so in the official documentation of the Kubernetes also, they have written that the pod is the smallest unit of the Kubernetes. So inside this pod, we have the containers, and these containers are managed by the container engine. So now the kubelet is also present inside each and every in the manager node as well as the worker nodes. everywhere the kubelet is present. So even why you might have the question that kubelet is present inside this manager node. What is the purpose of? Because here we are not creating any pods. See, the components, whatever the controller manager, or else the scheduler, or else etcd, API server, whatever the components we have in the controller plane, those all will be treated as the pods only for the Kubernetes itself, right? For the Kubernetes, it will be treated as the pods. So that's the purpose that is the purpose, and that is the reason we have the kubelet here also. So each and every, as per the Kubernetes, it is going to treat each and everything as in the form of pod only. So it is the smallest unit that you need to remember. And moving to the controller plane, whatever the components that we have, these are the major components. One is the API server. So the first interaction will happen with the API server only, with the user. So by using a tool called kubectl, as I told you. So once the API server receives the data and it is going to transfer to the etcd, so the data will be stored here in the form of key value pairs. So and here something called scheduler is there. This is responsible to schedule the pods only. It is not going to create any pods or delete or manage any pods, but it will just schedule the pods. But it is going to monitor the nodes, whatever the nodes are there. So it is going to monitor the resources and the consumption, what type of CPU it is going to consume. Based upon that processors and all, it is going to schedule the pods and deploy, and it will tell the API server to deploy the pods here. So API server is going to tell the kubelet to do this job. So immediately kubelet is going to communicate with this container engine, and it will ask to. So kubelet it will create the pods, and inside these pods the container engine will communicate with the Docker hub, and from there the containers and the apps are going to get created. Okay, so one more last thing that we have is the controller manager. So controller manager is like, as I told you, it's like a supervisor. So it is going to monitor entire your cluster along with the manager node as well as the worker nodes. So it will take entire cluster responsibility and check and monitor each and everything working properly or not, and it is going to gather the information which is available in the etcd, and it will check the real-time information also. If something goes wrong, it again inform to the API server to do this job. So here in the controller plane, we have multiple manager nodes also. We might have. Not here I have for your understanding, I have drawn here only one manager node, but in the real time, to maintain high availability, we must have the multiple manager nodes also. Okay, so there should not be any downtime, and whatever you can create n number of manager nodes also, no problem at all, but the architecture remains same. It will not change. Okay, so that's the reason main Kubernetes is very important, right? So in the production grade. Okay, so this is all about the architecture of Kubernetes, and if you like this video, please do like, share and subscribe, so many people can learn whatever the concepts that we are going to discuss.